Okay, hello everyone, good afternoon. So this session, it will be a revision session for week 1 to 5. So we'll just wait for 2 more minutes before we start. Okay, good afternoon everyone. Welcome to this live session. So in this live session, we will be doing a revision of weeks 1 to 5, right? So uh, yeah, we'll also be having revision sessions this week and next week. So uh, hopefully you'll all get your doubts cleared. So this in this session we are going to focus on week 1 to 5. All right. So what we'll do is we'll try solving some questions, and as we solve those questions, we can also revise the concepts which were learned in those weeks. Hopefully, if you have other doubts in that topic, we can discuss that as well. Okay, so that is the agenda for this live session. So all of you can join this peer deck. Go to joinpd.com and type this code OQWMAM. I'll share the link in the chat as well. Okay, you can go to joinpd.com, type OQWMAM. Yeah, just wait for a few seconds. I hope all of you, there are around 24 people in this call. Yeah, I hope all of you can connect to this peer deck. Okay, only 5 connected till now. Others also, please join this presentation. I'll share the link again. All right. Okay, I'll just share the link again. Okay, so you can go to joinpd.com, type OQWMAN, right? So this code is there at the top as well, top right of the screen. Anytime you want to join, you can join. All right. So let's get started with some questions from the initial weeks, right? So, okay, this is the first question. I'll give you 2 minutes to read, and I want you to answer this question. So this is related to asymptotic notation, which we learned in week 2. Yeah. All right, I can see 12 of you have responded. Do you need more time? Let's check the responses. Okay, let's see. Okay, very nice. We have a good uniform distribution, almost uniform distribution. 3, 4, 5. Okay, so I want, yeah, so I want anyone to respond. Like, why did you choose your option? What was your reasoning behind that? Okay, so I'll just, yeah. Any of you can unmute and speak.
Yes, sir. I chose option B.
You chose option B. Okay,
Okay. Because, sir, theta denotes average case complexity, right?
right.
And Wn is worst case complexity. So if we take theta of that function, so it will give us the average complexity.
Okay,
So that is why I chose option B.
all right. Okay, so anyone has any doubts on in this notation, theta, big O, sigma, sorry, rho?
Kind of lost track there. It's been a long time since we saw this notation, so it's kind of confusing right now. So it'd be great if you can just go over them or skim through them once.
Yeah, sure, sure. How do you read that? Okay, all right. Uh, okay, right. So there are three notations, right? One is known as this big O, right? And then okay, this is the rho or whatever. So this is the worst case or the upper bound complexity, right? this is the best case or the lower bound, right? And theta is like the average case, or you can say it's like it's a very tight bound. Okay. Now, what do we mean by that, right? So let's say we have a function, some function like this, right? Let's say this is f of x, right? Now, okay, sorry. Let's say we have a function like this. It's going somewhat like this. Now I have another function, okay, which might be going something like this. And after a particular point, right, it is always, so okay, so this is f of x, let's say, and this is g of x. After a particular point, okay, of x, right, it is always the case that g of x is greater than or equal to f of x. Okay, after, sorry, g of x is, no, or we'll write it the other way around. F of x is less than or equal to some, you multiply some constant c to g of x, right? So after some x greater than x naught. So let's say this is our x naught. So after a particular point x0, it will always be the case that c into some constant multiplied by g of x will always be greater than f of x. Okay, so in a way you can say that this g of x is always the upper bound of f of x. F of x cannot increase beyond g of x for all x's above a particular x naught. So after an x naught, g of x will always be greater than f of x. Is this clear? So we say, okay, so we say f of x is big O of g of x. So whenever you see something like this, what you can always think about is you can always replace it with this, which tells you that f of x is less than or equal to g of x after a particular x. Or the other way to think about it is g of x is always the upper bound of f of x. Okay, is that clear? Then, yeah, then of course the best case or the lower bound is the other way, right? You have some other function, let's say h of x, which or which might be greater, but after a particular, let's say call this x1, after a particular x1, let's call this h of x, no? After a particular x1, right? It will always be, or let me write it. Yeah. So in this case, my h of x or my f of x will always be, remember this is my f of x. My f of x will always be greater than or equal to c of h of x. Or the other way to think about it is this h of x will always be a lower bound. So if you can see h of x after this particular x1, h of x is always less than f of x. h of x is always less than or equal to f of x. So this is like the lower bound. So then we say f of x is equal to rho of h of x. Okay, and then theta tells me that I can have a function. Okay, now let's call it yeah. So let's say I have f of x. If f of x is equal to theta of let's take f1 of x. What that means is that for a particular value x0 and x1, okay, and some constants c c0 c1, right, f of x will always lie between f1. So if you have something like this, so let's say this is f of x, and you will always see that there you will always get f1 of x, right? So this f of x will always lie between these two values of f1 of x. So it's a very tight bound, right? So that is what theta means. All right. Okay. Let's go back to the question now. Now the question was, so now we have an algorithm, right? We have an algorithm, okay, in which okay, Wn is the worst case. So Wn is the worst case, okay, and we have An is the average case. Okay, now that you have gone through this explanation, I just take let's take 2 minutes, and I want you all to if you want to change your response based on what we discussed, you can think about it. Just give you 1 minute to, if you want to change your answers, you can, otherwise you can keep it the same. Okay. So we have Wn and An, and based on what we discussed, what do you think is the right answer for this? Okay, let's see if there's any change in the response. And others who haven't responded, you can always respond. I'll post the link if you don't have it yet. Okay, let's see what the responses are. Okay, slightly more towards option C. Okay, let's see what option C says, right? Option C is saying A of n is equal to big O of Wn, right? And remember, whenever we see a big O, what we can do is just replace it with this, right? F of x is equal to big O of g of x. What that means is f of x is less than or equal to some c of g of x, or g of x is like the upper bound of f of x after a particular x value. So if I replace that over here, so a of n is less than or equal to some c into w of n. So what does this tell me? So my average case running complexity is less than or equal to my worst case complexity. Is it right or is it wrong? What do you think?
It is right.
Sir, it is right.
It is right. Okay, others who chose option A, B, let's look at A, no? A is saying A of n is rho of Wn. Remember, rho is the average case. Sorry, the lower bound, right? So whenever there's a lower bound, you have to just replace it with this greater than or equal to. So what does that say? That tells me that my running time for A of n is greater than or equal to some c into the time required for my worst case. So is this right? So this is option C. This is option A. What do you think about this? Yeah, this is the opposite of C.
It's actually, so whenever we talk about an average, worst case will be the highest amount of time, right? So when we talk about an average, obviously it should be less than the worst, like the worst case, which takes the highest time. So that's why this doesn't make sense.
Right. Any doubts why this is not right? Okay, good. Now B, why is B wrong? Let's check B. So A of n is equal to theta of W of n. So remember, what we have to do is A of n is bound between some C1 and C2 of W of n, right? And again, this is, we just said that A of n cannot be greater than or equal to greater than W of n for some C1. So this also does not hold. So the correct option is C. All right, I hope this is clear. Any doubts? Okay. Now let's move on to the next question. Okay, I'll give you 2 minutes to answer this. Others who have joined, please participate. You can go to joinpd.com and type this code OQWMAM, or I'm sharing the link on chat also. Okay, 12 of you have responded. I'm just waiting for a few more responses. All right, let's see what the answers are. Okay, so we have option B, option A, and option D. So many of you think it's option B, some of you think it's A, and some of you think it's D. Okay, so none of you say it's option C. Okay, so let's see what option C says. Okay, so all of you are saying it, one of the equalities hold, right? That's what you're saying. Okay. So any of you who answered option B, why do you think it's correct?
Am I audible?
Yes, yes.
Because Fn is greater than Gn. So it means that Fn will be upper bound for Gn. And inversely, Fn will not be, Gn will not be upper bound for Fn. So that is what option B says. Because Fn is greater than G.
Okay. Okay. Thanks, Gagni. Thanks. Okay. So you said that Fn is greater than Gn, right?
Yes, sir.
Okay. So how do you know that? How can you be sure that Fn is greater than Gn?
Okay, so Fn is equal to n square log n, and Gn is n log n raised to power 10. So with the log properties, the n raised to power 10, the 10 will come in front, 10 n log n.
So you're
So now
saying n log n raised to 10. So
so
you're
10
saying,
will come in front of n, like 10 n log n. It will become 10 n log n with properties of, yeah. And now here log n and log n is same in Fn and Gn. So n square is obviously greater than 10n. So that is how I inferred that Fn is greater than Gn.
all right, all right. Okay, very good, Gagni. Very nice. Okay,
Thank you, sir.
all right. So anyone has a doubt on how we got Gn is 10n log n? Okay, I hope there are no doubts regarding that, right? So now we have Fn, which is n square log n, and we have Gn, which is 10n log n. Okay. Now let's take examples, right? Now let's take n as 1. But let's take it like this, right? So for n, when n is 1, what is the value of Fn?
Zero.
Yeah, so log n is 0. So we see that both of them is log 1 is 0 for both the cases. So Fn and say g of n both are 0. Oops. Sorry, yeah, right. Now, yeah, now let's take for 2, 2, 3, whatever, right? So now for n equal to 2, which of the functions are greater? Can you tell me? Which is greater, f of n or g of n?
G of n.
Yeah.
But g of n, and for n equal to 2, g of n is in fact greater, right? So this is the red. G of n is greater, which is log 2 is, let's say, 1, 10 twos are 20, whereas here 2 twos are 4, right? So it will be somewhere over here, let's see. Then what about 3,
Gn.
Gn.
right? Still Gn is greater, right? So this is some 9 something. This will still be higher somewhere. So at what point do you think will this trend continue? Will f of n always be, sorry, always be lesser than g of n?
At 10, both of these functions will be equal.
10. N equals to 10, it will be equal. And then from that, after that, Fn will become greater.
Right. So something like this is a very rough thing. This is, yeah. Then after that, we see that after this point, right, f of n will become greater and g of n will always be lesser than f of n, right? So the actual thing to note is that g of n will always be lesser than or equal to f of n for n greater than or equal to 10. Therefore, g of n, therefore, g of n is equal to big O of f of n. And not the other way around, right? Okay, is this clear? Any doubts regarding this? All right. Okay, very good. So, okay. So that's the reason why g of n is f equal to O of f of n, but not the other way around, right? Okay, good. Okay, this is the next question. Yeah, the question is which of the following options are true? Okay, which of the following claims are true? Yes, yes. The question is which of the following are true? Like A says 1 and 2 is true, B says 1 and 3 is true, C says 2 and 3 are true, and D says all 3 are true. Okay, that's the question.
Sir, here in the first option, k is smaller than n, right? K is a constant and it is very smaller than n.
Yeah, sorry about that. Yeah. K and M are constants. Yeah. K and M are constants. Yeah. And it is smaller than N. Yes. Yeah, sorry, I missed that. Okay, I see many more have joined. Yeah, if you have not joined the PD link, just share. Okay, others who haven't joined the peer deck, please, I've shared the link. Please join. Okay, 15 responses have come so far. Do you need some more time? All right, let's see how you all have responded. Okay, again, a good distribution. A, B, C, D. Many, slightly more have said A. B and D are tied. And option C, 3 of you have responded. Okay, let's look at the question. Okay, any of you want to respond? Okay, I want someone who hasn't spoken yet. Okay, Priyanka, go ahead.
Sir, I think all are correct, because if we look at n plus k, for example, here k could be equal to n. In that case, it would nothing but 2n raised to power m, which is nothing but a constant, and n raised to power m. So it becomes like sort of big O of n m if we ignore the constant. Similar is the case in the second one, because we get again 2n into 2, which is again 2 being a constant. And in the third case also, sir, it is like 2 square into n, which is also nothing but a constant into 2 raised per n. So again, big O of 2n. So I think all the three are correct actually.
But in the third option, it is 4 raised to power n, and the option it is saying like order of 2 raised to power n. Won't it be different?
No, see, it is like 2 square into n, no? So it is
So
nothing
2
but
square
like
is 2 square is 4 na. So it is 4 raised to power n.
no, that is correct. But actually, what happens if you put like sort of it also, because at least I think, for a particular this thing, after a particular number, 2n will sort of govern, and big
But
O, that
the
is what
thing
I
is,
thought.
if we are calculating this in linear equations, then we can think of it like now the situation is like here the third option is in exponential form, and in exponential form it grows very fast if we multiply it by 2, 3 or some constant also.
No, actually, I was thinking more, if you look at, how logarithmic thing grows, that 2, if you take it to the base of 2, actually, it will not make much of a difference. So
But here
I am rationalizing like that.
it
Actually.
is exponential, not logarithmic.
नहीं, वो correct है, no doubt. Well, at least that is what I was thinking, that it is like all three are correct.
All right. Okay, good discussion. Okay, so others, I want others also to respond. Any other options which you chose?
My thought was all of them were false first.
Okay, who is this? Sorry, I can't.
Shiva.
Yeah, Shiva. Okay, all are false.
So,
Okay.
yeah. So
go ahead.
because, again, maybe because it's been so long since I did it, that's why I forgot. Again, I'm just thinking because there's a constant of k getting added there in the first term, and we just talked about how I'm just talking about what we just earlier talked about. Big O. Big O is it's like a notation saying the function in the big O is always greater than or equal to the function on the left.
Okay, so
right?
let me just write that. Yeah.
Yeah.
So what you're saying is
n plus
this
k whole power n
function
is less than or equal to
some c constant and n
n
to the power n. Yeah, go ahead. Yeah.
Oh, okay, we have a c there. Okay, I forgot about the c. Okay, now I'm thinking. No, I was just my thought process was, since we're always adding a constant k to a given n, that will definitely be greater than just the n power m, which is inside the big O brackets. Then I thought that's why I thought it was false. That's the same logic I used for all these three, and I said all were false. So yeah,
Right.
please, can you like explain this once?
Right. All right. So yeah, so now what we have to do is in a way what we are saying, and remember k is a constant, right? It doesn't change based on n, and m is also a constant. Okay, sorry, I did not mention that clearly in the question, right? So what that means is your n can keep on changing, but your k and m will always be a constant, right? So in that case, is this inequality true or false? Right? That's basically the question we need to ask. What do you all think?
Don't we have to fix that c first in order to, so basically we are saying less than or equal to, we are saying that after a certain point n, the c dot or c into n power m will be greater than, definitely be greater than n plus k whole power m. Now, doesn't it depend on c now? Is my question.
Yes.
Doesn't it? Yeah, that's one. Again, I'm just thinking, but yeah.
Yeah. Right. It does depend on C, right? But what it's saying is that if we choose a particular C and after a particular, let's say n0, so for all n greater than n0, will this inequality hold?
Yes, sir.
Right?
So did you
It
mean
will.
to say n not greater than or less than n?
Yeah, so should it be greater than or should it be less than?
For a value of n which should be which can be more than n, I think, for all.
Yes. For all and not greater than. Okay, yeah, sorry.
Yes,
For
that's the yes.
sorry. For
Yes,
all
that's okay.
n, yeah, for all n greater than a particular n naught, right? So what it is saying is that let's take this function as say n to the power n, and we have another function n plus k to the power n, right? So will c into n of m be an upper bound? Like after a particular value, will c into n of m will it always be an upper bound for n plus k to the power n? Right? And that's true, right?
Yes, sir.
Anyone has a doubt why this cannot be true, or why this is always true?
It's clear.
All right. Okay. So one seems to be true. Okay. Now, what about two? Let's look at two. What do others say? How
Sir,
will we?
in second question, in second point, if our c is greater than 2, then this equality will hold.
Okay, just a moment. Okay. So you're saying again 2n plus 1 is equal to big O of 2 raised to n. So I will replace this by, I will have some c into 2 raised to n. Okay. And what you're saying is, when will this be true?
Sir, for all c greater than 2.
For all c greater than or equal to 2, right?
Yes, sir.
And for all n, actually, right?
Yes.
So this is definitely true. Okay. Any doubts in this? Okay, so are there anyone, is there anyone who thinks 3 is true? Yeah, Priyanka said. Anyone else who thinks 3 is true? Then we can work through that also.
No, sir, I have understood. My 3 is not correct. I have understood. Yeah.
No, it can be correct also.
No,
Does
why it
anyone
is,
else?
sir, why it is not correct? I am remembering now that, we made a lot of effort to change that n square to 3 into 2 by n. Rather than 2n, we wanted to change to 3 by 2, decreasing it by 1.5. So I think it probably is not true that way.
All right. Okay, let's just think of it, no? So 2 raised to 2n. What we are saying, it is always lesser than or equal to some c multiplied by 2 raised to n. Okay, for a particular c and n greater than a particular value, right? Okay, so let's.
But C is a constant, right? So for this to hold true, C needs to be 2 power n. But C, again, when you say C becomes a 2 power n, it keeps changing. So that's why this doesn't hold true, because it's not a constant if we think that if we take this as true. I understand that, yeah.
Right. Very, very good explanation, Shiva. Yeah. So what Shiva was saying is, for this to be at least equal, right? C has to be 2 to the power n. Why? Because 2 to the power n into 2 to the power n is equal to 2 to the power 2n, which is my LHS. Right? But when you make C as 2 to the power n, C is no longer a constant. It is depending on n. Right? Got it? So that's the reason why this cannot be true. Okay, or maybe another way. What is another explanation? One way can be maybe try taking log on both sides, no? So log of 2 to the power 2n is less than or equal to log of c into 2 to the power n. Okay. Now this we can bring it down, so it's 2n log 2 less than or equal to, what can this be? Log c plus n log 2. So log 2 is 1. So 2n is less than or equal to log c plus n. So again, n is less than or equal to log c, right? Yeah, exactly. You get the same thing what Shiva was saying, right? So now if you take the exponent, it will be 2 raised to n less than or equal to c. So c should always be greater than or equal to 2 to the power n. It's not a constant, right? Because it depends on n. That's why 3 cannot. So 2 to the power 2n is not the big O of 2 to the power n. All right. Okay. Hopefully, with these questions, the asymptotic analysis thing, hopefully it's clear, right? So whenever you're in doubt, just convert this big O's and thetas and all into an inequality, and hopefully with that you should get the question right. All right. Now let's move to the next question. Yeah, we'll go into some sorting and the sorting questions which we learned in week 2, 3, and week 3 especially, right? And in this question, all this is big O, not theta. It is big O. So big O n log n, big O n log n, and big O of n square. Okay. Yeah, I'll give you 2 minutes to think about this. Okay, only 14 responses.
Sir, one doubt.
Yeah.
Sir, here the quick sort is the normal quick sort or quick sort using the medians of medians approach?
No, it's a normal quick sort.
Okay.
Traditional one. Yeah, maybe the pivot you can take as the first element.
Okay. Sir.
Okay, others, if you want to respond. Okay, let's look at the responses. Okay, many of you have said option D. Some of you have said option B. Okay, let's see. None of you have said option A or C. Okay, let's look at A or C. Okay. So you're saying A is not true because why? Why do you think so? Someone who has not responded till now.
Because insertion sort has like worst case complexity as n square.
All right. Okay, so that itself is gone, right? So all of you, I hope all of you are clear with insertion sort, right? Does anyone have any doubt regarding insertion sort? Why the complexity is n square? Right? Basically, insertion sort, you are looking at each element, comparing it with the other up to a particular point, and then rearranging or swapping them. And you do that for each element till you reach the end, right? So in a way, you're doing two iterations, right? That's why it can never be log n, right? It's always n square. So that rules out option A. And why is C not right? Okay, C, most of you have said n square, okay. And merge sort, all of us know that it's n log n, right? Why is it n log n?
So, sir, every time we divide the list in equal halves and merge them.
Right. Right. So remember, log n always is refers to, we are dividing it into half each time, right? And then we merge them, which takes n operations. So n log n is the running time complexity for merge sort, right? And quick sort. Okay. So quick sort, you're saying the worst case complexity cannot be n log n. Right? Okay. I hope that's clear. So what is the worst case complexity for quick sort?
It will be n square.
It will be
N square.
n square, right? And under what conditions does it become n square?
So if our pivot is like, if our list in ascending or descending order, then the pivot will be like, it will not be around the median element. So the list will be divided into two parts of length 1 and n minus 1.
So let's say this is a list, right? Okay, so what will merge sort do? Merge sort will, yeah, just to reiterate, merge sort will divide this, then divide this, then divide this, and go on, right? So that's why we get it as always n log n. Okay, what happens at quick sort? We
It will,
choose a pivot. Yeah, go ahead, Viraj.
so we'll choose the pivot element as 1
Hmm.
and move all the smaller elements to the left of this pivot and the larger elements to the right of this pivot. So here we can see all the elements are greater than this pivot element.
Hmm.
So the larger part is of length n minus 1.
So this is n minus 1, right?
So here we are not dividing the list in two equal parts.
Right. So this is like we call quicksort with n elements, and then we call quicksort again with this, right?
Yeah,
N
approx.
minus 1 element, and then
N minus 2, n plus n minus 1. This will like, this will be the formula of sum of n numbers, n into n minus 1 by 2.
right,
That
right,
will be basically n square.
right. So in such situations, right, when the list is sorted in ascending or descending order, quicksort, if we take the normal traditional quicksort of, taking the first element or the last element as a pivot, right, it will result in an n square order n square running time complexity, right? And that's why the worst case running time of quicksort is big O of n square. Right? So I hope that is clear. Right? Any doubts? So the correct option is D, right? Okay, Arshia is asking C would be correct in case of theta. Yes. Do you all agree? The average time complexity is, yeah, it's T.
Yes, sir.
Right. Thanks, Arshia. Yeah, that's correct. All right. Okay, good. Right. So just keep in mind each of these sorting algorithms, right? What is the basic idea? And then based on that, you can answer the questions, right? Okay. This is a similar question. Yeah. So which of the following cases are true? Okay, Gurneet, the final answer is D, option D. Because we know insertion sort, it's always n square. We go. Merge sort is n log n. And what we just mentioned about regarding quicksort, when the list is already sorted, it reduces to an n square algorithm. All right. Okay, the next question. I give you 2 minutes. Okay, others who are joining, please join the peer deck, right? I've shared the link again. Okay, I see 15 of you have responded. What about the others? This is like a continuation of the previous question, so I hope all of you will get it right. Does anyone need more time for this question? All right, let's see the responses. Okay, most of you have said option C, right? Let's see what C is saying. 1 and 3 are only true, right? So we just saw that when the list is already sorted or it's in the ascending order, quicksort runs in big O of n square type, right? So that is definitely true, right? But what about insertion sort? If it is sorted, does insertion sort run in big O of n time?
Yes, sir.
The function stops in one step.
Because we don't need to insert the element, and the inner loop will be redundant. If like we are inserting the element, we'll just insert it at the end of the list.
Okay. But does that mean it runs only in big O of n time?
Yeah, yes, sir. Because we have to simply loop through the complete list.
Okay. What do others think? Anyone else thinks this is correct, or does it run in
Mostly it's like it just compares all the first element with the next, and since it's in ascending order, it just keeps on comparing with all the elements and sees that everything is true. That's why it does one whole iteration through the whole list, and that's why it's ON. This is what I think.
all right? Anyone else? Okay. And what about merge sort?
So each time we have to divide the list in two equal halves and check that recursively. So it will at least take n log n time.
Right. So irrespective of how you order it, right? Merge sort will always take order and log n time, right? So I just want to think we have a summary here. No? Sorry, which was that question? Insertion sort, right? So let's look at an implementation. Yeah, this is the implementation of insertion sort, right? Yeah. So if the list is already sorted, right? Let's see what happens. 1, 2, 3, 4, 5. Okay. So for I in range of n, j is equal to, so we'll start with I as 0, j is I, so j is equal to 0. Yeah, so we don't do anything there, right? And then j becomes 1, right? Now j is greater than 0 and L of j.
So
So what is it?
first I will become 1, then j.
Oh, sorry. Yeah. I will also become 1 and j is 1. And while j is greater than 0, so remember our pointer is here and L of j, this is less than j minus 1. Okay, so that's not the case, right? So we won't run it, right? And then what happens?
I will become 2 now because we will
I
not
will
enter
become
the while loop.
right. We won't enter the while loop. I will become 2. J will also become 2. So each time we will skip the while loop because we L of j, wherever j is, it is not less than L of j minus 1, right? Correct, Arshia. So it will never enter the while loop. So each time you are just iterating through this j equal to I and you're iterating through the, you're iterating through the for loop, right? So is it clear? Yeah, but I'm just, right. This case, that's why this is 1 plus 1 plus 1 n times, which is equal to big O of n. Okay, I hope this is clear. Quicksort, we said, merge sort, right? Irrespective of the values, we have to divide the list every time, right? And what about selection sort?
So in which case?
Selection sort.
It will always
Selections.
be n square.
Yes, sir.
Right? It will always be n square because we always have 2 for loops,
Yes.
right? All right. And we are always entering through that. And if we are checking, if the check might not be true, right? But we are always iterating through the loop.
Then
That's the reason,
calculating
right?
the minimum element in the remaining list.
Right. All right, good. So I hope sorting algorithms you all are quite clear. Okay, let's move on to graph traversals then. Okay, which we learned in week 4, 5, right? Yeah, you can go through this question about BFS. Yeah, I'll give you 2 minutes to answer this. Okay, only 6 of you have responded. Yeah, this would require you to take a piece of paper and draw the graph. That's why, yeah, please take that effort to do that. Yeah, I'll wait for some more time. Others also please attempt this. Okay, let's see. Do you need more time? Let me look at the responses. Okay, most of you have said option B. Okay. V1, V4 is a VH saying. Okay. So how do we solve this problem, right? We look at, yeah, we just draw the graph, right? V1. So we have an edge from V1 to V2. Then we have an edge from V1 to, let's say, V3. Then V1 to V4. V2 to V4. V2 to V5. V3 to V4.
4 to 5.
V4 to V5. V4 to V6. V5 to V6. And V6 to V7. Right? And a BFS is performed with V1 as the root. So we start with V1. Remember what BFS does? So which all nodes will be visited next? Can
Level
you
by
tell
level.
me?
All its neighbors, V2, V3, and V4 will be under its tree, like edge.
All right. Very nice. Okay, V2, V3, V4.
Now
Okay,
going
next.
through the ascending order, we'll go to V2 and then its
Okay.
neighbors we'll see. So V2 has its neighbor as V5.
V5. Okay. But what about this V2 to V4 I can connect?
It's already under V1 and V1, so it's already visited. So
Right.
visited
Right.
it,
So
it will not visit it again.
right. So for graph traversals, we once we visit a vertex, we do not visit it again. Right? Okay. Next.
Now V2 is complete. Now we'll go to V3. Now V3's neighbors are also already visited. That is V4.
Okay.
So now we will go to V4.
All
V4
right.
has its neighbor as V5 and V6. V5 is already visited, so V6 will be under V4.
All right.
Now V7 under V6.
Okay. V5 also we will
Visit.
look at its neighbors. Yeah.
It has V6 and V2 that are already visited.
All right. So this is the BFS tree for this problem. Anyone has any doubts how we got this? All right. So which of the following is the tree edge? V2 to V4? No. V1 to V4? Yes. V4 to V5? It's not there. V3 to V4? It's not there. So V1 to V4 is the right answer. Okay, I hope
One
this is clear.
question I had here was
Yeah.
this depends on the choice we make at the neighbors of 2, 3, and 4, right? So
Yes.
V4 and V5 might as well be a tree edge if we first choose to visit V4. Okay, so it depends on the implementation basically.
Yes. Yes. Yes.
Okay.
Yes.
Yeah, that's it.
Yeah. Yeah, that's a good point because we choose or we can choose any of the. So, for example, Shiva's question is, so let's say we chose V1 first. We are starting from V1, and then we put these three vertices, right? These three edges, V2, V3, V4, right? Now, which vertex do we choose next? Because we have V2, V3, and V4. Okay, I like theoretically we can choose any one, right? But most standard implementations, each of this has a number. So we choose the one with the minimum number and we move forward, right? Yeah. So for all questions, traditionally or we mostly we denote we choose the neighbor based on its vertex number unless otherwise specified. So that's the reason why we got this. All right. Okay, let's look at the next question again, BFS. Yeah. Okay, what about others? I'm waiting for the others also. Only 8 responses till now. Do you need more time? You can reply on the chat if you need more time. Okay. Okay, let's look at the responses. Oh, very nice. All of you have chosen option D, right? So I hope it's clear, right? So what is the question asking you to do? If let's Right. Graph must be traversed level by level in BFS. So and this gives you the first node gives you the clue or gives you the idea that that is the node with which the traversal started, right? So if we start at M, then N, Q, R should be the next three vertices in some order, right? But here you can see it's N and O, so that's ruled out. In this case, if we start with N, then we know it should be M, Q, and O in some order, but that's also not. Q, M, and P has come. Then if we start from Q, then M, N, O, P should be there in some order. R shouldn't come, but R has come there. And the last one is P. Okay, I can't see that clearly. It's P, Q, O, right? So P, Q, O, right? So Q and O are
It is
the
POQ, I guess.
okay. POQ, right? So POQ. So if we choose P, then O and Q should come in some order. And okay, that's how it has come, O and Q. And if we choose O, then N should come, which is correct. And after that, we choose Q, we choose M, and finally we choose R. Okay. I hope this is clear. Most of you have got it right. So let's move on. Okay. This is the next question. Okay, I'm waiting for a few more responses. Okay, Nagarajan is asking, can you please explain the BFS traversal of question 8? Nagarajan, question 8 is the previous one. I've not noted down the numbers. Okay, the previous one. Sure. Yeah, we'll just solve this and then we'll. Okay, yes and no. The one before, right? Okay, we'll go to that. Okay, let me see the responses for this. Okay, we have a uniform distribution 3, 4, 5. I mean A, B, and C. Okay. Others, do you want to add? Like, which do you think is the right answer? Okay, let's look at the question. Okay, someone who hasn't spoken till now. Do you want to take a shot at this question? Yeah, someone new, someone who hasn't spoken till now.
Can I try?
Sorry, who is this?
So this is Ashutosh.
Ashutosh. Yeah, go ahead, Ashutosh. Yeah.
So, first of all, it is a binary tree, right? And the vertex is just at a distance 4 from the root, right?
Mm.
Then, first of all, we can make a binary tree of the height 4. The last root of it is farther from the fourth. It's the fourth edges in between.
Okay. Sorry, Abam, I think my internet was bad. Can you repeat, Ashutosh? Yeah. So
So
it's a
first of all,
binary tree, right? And we know what a
yeah,
binary tree is, right? It has, yeah,
two edges. Yeah.
it has 2 edges, right? Okay.
And we have to make a binary tree of length height 4. So height 4, such that
Okay.
the th vertex is at the last.
So what do you mean by height? What do you mean by height of a binary tree?
Means how can I say? Means the parent child have a daughter, and that daughter child have another daughter and another daughter. Like you can say by level.
Right. Okay, got it. So this is a binary tree of height. Let's say this is 1, and this. So this is a binary tree of height 2.
Yeah, no, sir, it is a binary tree of height 1 equals. If you are
Okay.
means,
All right.
if you are
So
starting from 0, then it is 1, and if you are starting from 1, then it is 2.
all right. Fine. So let's not get confused with that. Okay. So, but in this question, what are they saying? There is
The
a
vertex
vertex.
is 4 distance 4 from the root.
Okay.
For the
So,
we should make a binary tree of height 4.
okay. So 1, 2, 3. This much or one more, or this is fine?
No, sir. First daughter of the parent child, root child, should have another root, and another means that should be a full binary tree. Therefore, it could be maximum possible value.
Okay. So you're saying that since the word maximum is there, it should be a full binary tree, right?
Yes.
So what is a full binary tree?
Means every if there is a daughter, if there is a daughter child of a parent node, then it should be have two daughter child.
Right. So whenever there is a node, except for the leaves, every other node should have 2 children, right?
Yeah.
Okay. So yeah, I want to fill the entire thing, but let's just look at maybe one of them, right? So this will have something like this. Should I add more leaves, or this is the maximum?
No, sir. Another above should have also a right child.
One more, like this.
No, sir. No, not there.
So let's take this as node P. Okay. Now P is at a distance of how much from the root?
It's a distance from 3.
3, right? So, but what they're saying is this t is at a distance of 4 from the root, right?
And then it should have another chain.
Sorry.
I think, sir, his network is not stable. We are unable to hear him.
Okay, okay. Ashutosh, you're there?
Yeah, I'm here, but am I not audible?
Your voice is breaking so much, sir.
Yeah, it was slightly breaking in between, but it's okay. Yeah. So, no, I'm asking, should I construct one more like this, or this much is fine?
No, sir. I think it should be one more.
It should be one more, right? Because this is still at distance 3. So let's say I add one more. So till here, I have to construct a full binary tree, right? And okay. So if T is the nth vertex of this BFS traversal, so we know that this T is lying somewhere around here, right? One of them, right? Okay, and which should it be? Should it be this or somewhere in between?
It should be at last.
Or somewhere over here at the maximum, right? And so the maximum possible value, will it be here or somewhere in between or here, or will it be this?
The last one.
It will be the last one. Okay, why do you say it's the last one?
Because of the maximum possible value. If we search by PFS, then it should have the maximum possible value.
Okay. Right. So okay, got it, Ashutosh. Anyone else wants to explain? I think Agneet was saying something.
Yeah,
Yes,
so
Gagneet.
we can solve this question like they have said that distance 4 at from root it is at distance 4. So it means we have to make 5 levels. So from level 1, level 1 is the root, then level 2, second, third, fourth. So fifth till fifth it will be distance 4. Now to get the maximum number, like maximum possible value, if the numbers are starting from 1, 2, 3, 4, such this, so we can calculate it by getting the numbers in each level and not by just writing all. So in level 1 it's 1, level 2 it's 2, level 3 it's 2 square 4, level 4 it's 2 raised to power 3 8, level 5 it's 2 raised to power 4 16, and we can add them all, and this becomes 31. So maximum value will be 30. This is how I solved.
Okay. To repeat, what you're saying is, we know that T should be this one, right? Did you all understand how we got this? T should be the last leaf in a full binary tree of level up to level 5. Is that part clear? Any doubts regarding that? All right. And what Gagneet is saying is that at each level, like if you take level 1, we have 1, which is actually, if you see, 2 to the power 0. At level 2, you have 2 nodes, which is 2 to the power 1. Level 3, we have 2 to the power 2, which is 4 nodes, right? And so the number of leaves at a particular level is 2 to the power 5.
4. It will go to 4. Yes. 2 to 4.
Yes, sir. 2 raised to power 4 will be
2
maximum
raised
because
to
we are
power 4 will be the last.
Yeah, sorry about that. Yes. Right? Or so what you did is you just added up all of this, right? Which is 1 plus 2 plus 4 plus 8 plus 16, which is 3 plus 4, 7 plus 8, 15 plus 6, 31. Right?
Yes.
Right? Anyone else? Ashutosh, is this how you did it?
Yes, sir.
All right. All right, very good. Any other way? Arshia is saying we could use the formula of 2 to the whole tree for height 4. Yeah, Arshia, do you want to unmute and speak?
Yes, sir. It's the same way that you told. Am I audible?
Yes, Arshia, go ahead.
Yeah, we just calculate the maximum number of nodes that we can get for the height 4.
Right. So you're saying instead of adding them all together, another formula is at a particular level, the number of nodes, total number of nodes is 2 to the power, whatever is that level, right? Minus 1, right? This is level 1, this is 2 to the power 1, which is 2 minus 1. So we are at level 5, right? So that is nothing but 2 to the power 5 minus 1, which is 30. Right. And Ashutosh is giving the same. Yes. All right. So the answer is 31. I hope all of you understood that. Any doubts in this question?
Actually, one thing over here is that one could have straight away eliminated the even answers, the answers which are even, because it's a filled binary tree, so it has to be either 15 or 31.
Right.
So
Right.
then it's just the whatever is being explained.
Right. Good. Very good. Yes. All right. Let's go to the next one. Oh, someone had a doubt. Who was that? Nagarajan? Which question was it? Was it this one or this one?
Yeah, this one.
Okay. So what was your doubt in this?
I mean, if you go to the traversal, after going to V5 from V2, you break there. And then you go to V6 from V4. How is that?
So we get V2, V4, V2, V3, V4, right?
Yeah.
Now we choose the next how we choose it is we choose the minimum one, right? So we choose V2 next, and V2 has edges V1 to V1, V4 and V5.
Actually,
V4
can I say something? It's the breadth first search. So you have to complete one level. So you have to complete V2, V4, and V3. All of them are at level 1. Right? So you completed V2, then the next is either V3 or V4. Now V3 cannot be done because V4 is already exhausted. So you have to go to V4. It's just because of the breadth first search.
Right. Go ahead.
V2, V3, and V4 are at the same level. So have to be explored fully before going down.
Right. Thanks, Naveen. Yeah. Was that the doubt, Nagarajan?
Yeah, so you explore V2, V3, and V4. After that, you choose to explore V2, right?
Yes.
And then from V2, you can go to V5.
Yes.
But then why don't you go to V6 from V5?
Because of the breadth first search. First, if you are
V2,
then you have to go to V3 and V4 before going to V5.
Yeah,
Because
another
V5
thing.
is at the next level.
Yeah, I think what we need to remember is we are implementing, we are using this using. You think about it, you start with V1, right?
Yeah.
And you put all of its neighbors into the queue. Okay. So
Yeah.
what is V1? V1's neighbors are V2, V3, V4. Okay. So now the visited ones are V1, V2, V3, V4. Okay. Now which do you choose next? The neighbors of the front of the list, which is V2.
Great.
Okay.
Yeah,
So
and
then
that
you,
is not unique. I mean, you could have chosen instead of V2, V4 also could have been chosen. And then the tree would have been different.
if I had put in the queue,
Yeah,
V4, V3,
exactly.
V2. Yeah. 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 Oh, that was your doubt, huh?
Yeah, I mean, if you take B4 now,
Then tree would be different.
yeah, tree would be different. So would that change the answer?
Right.
Then would you
Yeah.
have to draw all the trees?
No. So the convention which we have used is, we choose the vertex with the minimum number first.
Okay.
Yeah.
Lexicographical order.
Yes. Yeah. So ideally, yes, in the question that should have been mentioned, but since it's not mentioned, we can assume that it is taking it in that order. Yeah.
So you take the lowest and then based on that you arrive at a choice.
Right.
Okay. Okay. Fine.
Right. Is it clear now?
Yeah. Okay.
Okay. Thanks. Let's move on to the next question.
Sir, if you remember, we had a long discussion on this question in one of the sessions.
Yeah. Just want to revise this.
పాలు తన్నీళ్ళు పోతున్నా
Okay, 9 of you have responded. I'm just waiting for a few more. Okay, let's see, look at the answers. Okay, 1, 3, and 5. Okay, so in this also we have a somewhat, we don't have a full consensus. Okay, someone who hasn't spoken till now, do you want to try it, give it a shot? Someone who hasn't spoken till now? Anyone? Okay.
I have a question in like about the question itself. One thing I want clarity about is what does actually the connected component mean is what I want clarity about. So what I thought it was is just a pair of vertices which are connected with an edge. So that's what I infer it as when I saw the words connected component. And depending on that, I have given my answer. But again, I just want to clarify what exactly means, or is there a standard definition and I completely missed it, or something? That's it.
Yeah. So does anyone want to say what connected component is?
Yes, sir.
Yeah,
So,
Viraj.
Seva, let us consider a case we have a lot of vertices in a graph, and
Okay.
let's consider we have 10 vertices.
Okay.
And like third row, 4 of them are connected, 5 of them are connected already. There's a separate 3 vertices which are connected with themselves, but they are not connected with this graph.
Okay.
And we have 2 vertices which are connected with each other, but not with this graph. So in this case, we have 3 connected components.
Oh, okay. Okay, got it. Okay. I think I got it. So basically, a group of nodes which are in themselves fully connected, but maybe connected with some other group of nodes. Got it. I think I got it now. Yeah.
Yeah. This is a complete graph, but each of its components are not connected.
Oh, is it still a complete graph though?
I mean, all these vertices form a graph, but this is not a complete connected graph.
Okay. Yeah, it's not a complete connected graph. Okay, got it. Yeah. Yeah. Thank you for that.
Yeah, thanks, Viraj. Thanks. Right. So connected means from a particular node, you can reach to all the other nodes in that component, right? So if from here you can reach this, right? From here you can reach all the other nodes. So a set of nodes are said to be, a component has a set of nodes, such that from one node you can reach any other node of that. Then it is said to be a connected component, right? So in this case, we can see that there are 3 components, right? So this is component C1, this is component C2, this is component C3.
I
Right?
think there is a problem with C3. It's a cycle basically. So one edge has to be removed if it is to be tree. Right?
Yeah, I hope so. Yeah, thanks for pointing that out. Right. Right. And so what they're saying is a depth first traversal of a graph, it has n vertices and it has k edges. So actually this is a DFS. Okay, let's take this as a DFS, right? As someone pointed out, this is a DFS which we get, right? And the number of vertices are n. And we are saying that there are k edges, right? K edges in this DFS. And the question is, how many connected components are there? right? Right. So yeah, now that I've told this, can you all try to see or try give a shot on how we can think about it, or maybe just choose one component and see if there is a relationship between n and k. Let's say C1 has n1 nodes. How many edges are there?
N1 minus 1.
N1 minus 1. Why? Why will it always be n1 minus 1?
Because it is a tree, sir. It is not making means it does not make cycles like that.
Very good. Very good. So that is one observation, right? When whatever is if for a particular component, right? If it has some n1 nodes, then the number of edges will always be n1 minus 1, right? Since we know it is connected, right? Similarly, so n2 is n2 minus 1 and n3 is, let's say, n3 minus 1, right? Now, if I add up all of this, right? If I yeah, let's say if I add up n1, yeah, if I add all these three together, n1 minus 1 plus n2 minus 1 plus n3 minus 1. In a way, I'm saying, or if I add up all the edges together, what should I get?
K.
Number of tree edges.
Yes, the number of tree edges, which is k, right? But we know n1 plus n2 plus n3 is
N.
it is n, right? And each of this component in a way is subtracting 1, right? So it minus 1 hai, minus 1 hai, minus 1 hai, which is actually minus 3, which is equal to k. So this in a way is referring to that particular component, and when you add all of them up, it refers to each of those components, right?
Total
Yeah,
number
basically
of
the number of
components.
components.
Total number of
Yeah.
components.
Total number of components, yes. Right? So in a way, if we remove, let's C be the component. So n minus C is equal to k, or you can say that C is equal to n minus k. Right? There are many other ways to think about it, but this is one with an example. If you see this can work, or you can. Yeah, do you want to think of any other way you can explain this?
I arrived it in a very weird way. So what I did was I took all the nodes and n nodes. Then I thought, okay, let's simplify it. Let's just think. When I understood the definition of connected component, what I thought was take all the n nodes and think only two nodes are connected and everything else are disconnected. Like two nodes make one component, another two nodes make another component, and so on. And after that, then I thought about what the k value would be. K value would be n by 2, right? Because there are like pairs of connected components. So the k value would be n by 2. Then how many connected components are there? N by 2. So that's like n minus k because k is already n by 2. So I just like used an example because I know there is this standard way to arrive at it. So this example should also arrive at the same formula. So that's why I went to n minus k.
All right. Good, good. Right. Okay. So I hope this is clear. Okay, let's go to the next one. Okay, now let's go to spanning trees. I hope all of you all remember what a spanning tree is, right? Or should I just quickly explain what it is? Okay, I'll just quickly explain what it is. Meanwhile, if you know the answer, you can type it. Right? A spanning tree is it's yeah, you have a graph, let's say, right, of something like this. A spanning tree is a tree, right? And all of these have some weights, like say 100, 20, 3, 4, 5, whatever. You want to construct a tree in which the sum of all these weights are minimum. Right? So in this case, we choose this 1 and 2, but we don't choose this, right? Instead, we choose this to reach this node, right? Yeah, something like this, right? And the sum of all of this is the cost of that spanning tree, right? So in a way, it is telling me to reach all the nodes of the graph, right? What is the maximum cost, right? So let's say if this was the edge labels refer to how much cost or how much time it takes, right, to reach a node. So what is the minimum number of all of these? The sum of all of these, that is the minimum cost spanning. Right? Okay. With that information, I think you should be able to try this out.
Sir, in this question, there is no negative edges, right?
Yeah, yeah. There is no negative edges. Yeah. Will it work even if there are negative edges? Yeah, just think about that also.
Yes, sir. I think it should work even with the negative edges.
Oh, yes, sir. Yeah, understood. It will work with all the negative edges also.
Right, right. Okay, 10 of you have responded. Yeah, just waiting for a few more. Okay, let's look at the responses. Okay. Okay, I'm not able to see the exact values. Okay. 750, 2,500, 995, 995, 995, 1,000, 2,000. Okay, many 995s I see. 1, 2, 3, 4, 5, 1,000, 2,000. Okay. Okay. Yeah, someone who hasn't spoken till now, would you like to respond? How do we go about solving this problem?
Sir, am I audible?
Yes, Pras. Yeah, tell me.
Sir, there are 100 vertices. So in minimum cost spanning tree, there will be 99 edges.
Okay,
So
1 minute. So you said there are 100 vertices, right? So n is 100, but you said the minimum.
minimum cost spanning tree, there will be 99 edges.
No, how did you get this? How are you saying there are 99 edges?
Because whatever the minimum cost spanning tree there is, if the number of vertices is n, then n minus edges will be present there.
Okay. So everyone, is this clear? How we are getting 99 edges? Any doubts regarding this? Remember, it's a tree, and the spanning tree visits each vertex only once, right? And it includes all the vertices, and therefore it will have 99 edges, one less than the number of edges. All right, Pras.
Adding 5 to each edge, we are increasing cost of each edge by 5. So overall cost increase will be 99 into 5.
So for each of these 99 edges, you are adding 5, right? Which is nothing but you are multiplying it by 5. This is how much?
We add this into the cost we have got in the minimum cost spanning.
Right. So extra you are getting 495, right? And previously the weight was 500, right?
Yes, sir.
Right. So that's why the answer is 995. Okay, any doubts? I hope this is clear. Any doubts in this? All right. Okay, let's go ahead. Yeah. Okay, so now let's look at Dijkstra's algorithm. Remember, Dijkstra's algorithm is for from a single source, right? What is the shortest path to all other nodes in that graph, right? Does anyone have any doubts regarding Dijkstra's algorithm? Yeah. Okay, I'll give you a few minutes to answer this. All right. Okay, let's see the responses. Okay, most of you have answered option B, right? So I hope you all are clear. Just to summarize what Dijkstra is, right? What you do is you start from the source. The main thing to remember is this distance vector, right? And you iterate through the rows in the list of the matrix, right? And you choose the next node greedily, right? You see which is the minimum distance and which is the minimum distance in the distance vector which has not been visited, right? And that becomes the next D. And then based on that next D, you keep on updating your distance vector, right? So yeah, so let's see, most of you have said option B. Yeah, anyone wants to explain how you got B? B, two. Okay, what I'll do is, so we'll maintain this distance vector, right, for P, Q, S, P, U, and something like a visited. Okay. So initially P will be visited. Okay. So we have P. So what will be the distance vector initially? Yeah, any of you can unmute and speak.
So to Q it is 1.
To Q it is, okay, P is 0.
Yeah, P is 0. Q is 1. S is 6. And T is 7.
Yes.
Rest and rest all would be infinity.
Right. Okay. All right. And which is the next vertex which we'll choose?
Yeah, it is Q, which is after the lowest one.
All right.
So from Q, it would be R would be 1.
Okay, because we have a edge from Q to R.
Yeah.
So we look at the minimum of R and the distance from Q to R. So
Yeah.
this will be 1. All right.
And S would be 5 now.
It will be
P
5
to
because
S
we have,
would be 5.
right.
So actually, we are looking for P. So P to Q to R would be 2 actually.
Right. So it is Q was 1, right? 1 plus 1
1
is?
plus 1 is 2.
Yes.
So
sorry.
S would be 5. And
Yeah. So Q has only 2 neighbors, right? R and S. All right. Good. Now, which do we choose next?
Now it has to be R because
Look at the
there's
minimum.
nothing below 2 weight.
Right. Right. Okay.
So from R it would be 2, which is 1 is U. So the weight would be 3. R
Right.
to U.
Yes, 2 plus 1, which is 3.
And R to S would be weight 4. So S will get revised to 4.
Right, because we have the minimum of S, which was 5.
Yeah.
And
now you have another way. to go to S, which is 1 plus 1 plus 2.
Right. So whatever was the distance to reach reach R plus R to S, which is 2 plus 2, which is
That's the minimum one.
and that is the minimum. That's why
That's
we
the
have
4.
yes. Right.
And I think that's it. Can reach only at 2.
Right. Okay.
Then
Which
one
to
has
choose
to
next?
look at S, because that has no U probably. U.
Right.
But from U,
Because
one can't go anywhere.
Okay. From U, one can't go anywhere. Okay.
So it's S, which is 4, weight 4 right now. From S, one can go to T, and
Okay.
the
Okay.
weight
So
would
then
be 7.
from S, you can go to
But
T.
I mean, we have already been to T with weight 7, so there won't be any change.
So change. All right.
And that's it. Everything is
And
done.
you can go to U also, right?
Yeah, but that would be at higher weight.
That
We
will be
have
at
already
higher
been
rates.
3, so there's no
Right.
point.
Right.
So I think
And right.
it's all done.
And finally we go to T. Yeah.
Yeah. So that's what has to be.
Okay. So I hope all of you got this PQR UST.
Yeah, that's option B.
That's option B. All right. Okay. I hope that's clear. Let's move on to the next question. All right. Okay. Now this is Kruskal's algorithm, right? Kruskal, remember, is to find the minimum cost spanning tree. All right. Waiting for a few more people to respond. Okay, let's see what the responses are. Okay, so most of you have got it right, I think. Okay, all of you are saying option D. Yeah, anyone wants to say why you think B is the right answer?
Yeah, may I?
Yeah.
Yeah. So in
Go ahead.
Kruskal, you have to actually align the edges according to the increasing weight size, and then join them. So in the here the question is which one is not.
Right.
So you have to look at where the higher weight edge is coming earlier, which is in the case of D. So B is the lowest one. EF is 3. And after that, we are getting, so BE, EF is fine. Then BC. BC is a weight 4 edge. And after that, you have AC, which is weight 3 edge. So that is the
Right.
reversal where it is happening.
Right. Okay. So let's think of how we'll construct it, right? So as Naveen was saying, we start with the.
So first it has to be BE.
Right.
And then AC, EF.
Okay. So then, okay. So now that we have chosen B and E.
So this is with the weight 2. AC and EF are with weight 3.
Right. So one of them we can choose,
yeah,
right?
one of them.
So, right. Okay. So let's take AC for example. So if we take AC, it will be. Okay. Then after that.
EF.
EF because that is also weight 3. Okay.
And then weight 4, which is BC.
Weight 4 is BC.
And then GF.
Then
FG or GF.
Right.
That's weight 4. And then weight 5, which is CD.
Weight 5, which is.
But actually, I think, yeah, CB.
Sorry?
Yeah, CD. CD.
Yeah.
And that's it. All the edges are complete. All vertices are complete.
Vertices are complete, right? Yeah. And as you said, since here it is not in the increasing order of the weight edges, so that's the right. That's not the order. So that's the right answer.
Yeah.
All right. Thanks, Naveen. Okay. All right. So I hope these graph algorithms are also clear, right? Yeah, I think, yeah, we have just the final question regarding topological orderings, right? Okay, you all need some more time. Let's look at the responses. Okay, 5 have said option A, 2 have said option B, 3 have said option C. Okay, we have a, yeah. Okay, so let's see how we can solve this. Anyone wants to take a shot at it? How did you go about solving this problem?
May I?
Yeah, sure, Gavneet. Yeah.
So I picked the option A, 4, that is 4. So the possible orderings, actually topological sorting is like, it's like prerequisites, like we have to complete work A, then work B, then work C, something like that. So first of all, A is the first work that we have to complete before any. So A will come first in any of the orders, in any of the 4 orders. So now we have to see which
go
next we have to do. So after A, we can either do B or D. So any of the one, like B or D.
So I'm just referring it like this. From A, you can either choose B or D. Okay,
D.
why like that? Why B or D?
Because others, if we have to do first, we have to complete B or D. Like first, to do C, we have to do go through B, or for E, we have to go through D. So that's why. After A, we have to do either B or D. But B and D are not prerequisites; they are co-requisites. So we can do any of them, like first. So like we can do them together. That's also the thing. So
Yes.
A,
Yeah.
B.
So just to remind everyone. So what we do in topological sorting is we look at the set of vertices and choose the one which has the which has in degree 0, right? So there are no incoming edges to that node. So as Gagneet said, in this case it is A. And then what we do is we remove that from the graph, right? And remove all corresponding edges, outgoing edges also of that from that graph. And as Gagneet said, now we have 2 candidates whose incoming or whose in degrees are 0, B or D, right? So we can choose one of them. Okay, yeah, go ahead, Gagneet.
Now, for example, we chose B. So let's write our first order, A, then B. Now let's remove B.
Okay, let's remove B. Okay.
Now we can either choose D or C. So I chose D.
So when if we choose B, then you're saying we can either choose C or D. Okay.
Yeah. Now, for example, we choose C.
We choose C. Okay, we choose C. All right.
Now we have we can like we have D only left, like with in order 0, in degree 0. So
correct. Okay.
So after C we choose D. Now E and F.
Okay.
Like
So
when
we
we
choose
remove D, then E and F.
All right. Hello.
Yes, I'm there. Now E, as it has in degree 0, so E, and then F.
And then F. Okay. All right. So this is one possible ordering is A, B, C, D, E, F, right?
Yes.
Okay.
Now second one is like instead of C we chose D. So now we have 2 possible. After D we have 2 possible options. That is C or E.
Okay, 1 minute. So we have come here. So you have said we have removed A and B. Now we have C and we have,
Like
yeah,
we had
so we have removed A, B, and D. Okay.
yes. Now we have C and E. So two options under DTS, C and E.
Okay. All right.
Now, if we can, if we remove C, then F. After C, it's F.
Okay.
Oh, so sorry, not F. After C, it's E and then F. After C, it's E and then F. Similarly, after E, it's C and then F.
Okay.
Yeah, 3 done.
Okay. Now we have A we removed, so that's okay. But let's say we now remove, now we have come here, right? So we have removed A, we have removed D. Okay.
Okay, so answer will be 6, I guess. Sorry. Yeah. Like 3 more similar, like the under B, it's like the parent B under B, the trees are 3, right? Like the so similarly under D it will be 3. So from D we go to B or E. So to child B or E.
Right.
If we choose
And
yeah, B and E. If we choose B now.
oh, sorry.
Yeah.
Okay. So yeah. So I think we'll get a symmetric, somewhat symmetric kind of subtree here also, right?
Yes.
Like how we
Yes.
got this. So we got 3 paths here. Similarly here also we will get 3, right?
3. Yes.
So the total is
6.
right. So actually 6 is the right answer. Okay. So others who got 6, did you try any other way to get it, or this was the way you followed? All right. Okay. So I think that's all regarding weeks 1 to 5, right? So I hope these questions gave you an idea about the main concepts in these weeks, right? So yeah. So all the best for the quiz, for the interim and the PP. So yeah, we'll have revision sessions for the other weeks also in the next week, right? So yeah. All right. Does anyone have any other specific doubt regarding Snail? Will we have a session for OPP? No, I don't think so. Okay, everyone. All right, everyone. All the best for OPP and for the exams. Okay. Thank you, everyone. Take care. Bye.